The night is full of sparkling things. Things that glitter in crystalline brilliance. Things that dazzle the eye of whoever takes the time to look up and wonder.
The moon, the whole moon, and nothing but the moon.
John Dobson, PR man for the cosmos, salesman for the stars. Dobson calls himself a sidewalk astronomer. He wants the world to see and to wonder.
Over there. Come see the moon, come see the moon. Did she see?
Him, yeah.
Oh, him?
I could see the craters on the moon, and I'd never seen that before, and it was exciting.
Molto bello, beautiful.
Yeah, I can almost touch it.
Come see the moon. We're looking at the moon through the telescopes.
Everybody is born curious. Everybody wants to see this universe. Everybody wants to understand this universe. They're just waiting for somebody to present it to them. Everybody wants to understand this thing in his guts.
Astronomy is an endless quest into a universe of untold depths and mystery. This universe of light is only a small part of a greater universe of darkness.
Come see the sunspots.
Astronomers have always gone to where the light is.
The big green ball is the sun, the whole sun, nothing but the sun.
Dobson goes to where the people are.
And the spot that you see on my side, that's big, little bigger than the Earth. The sun's spinning from my side to yours. Now, if there were 1 million amateur astronomers with telescopes, and they were willing to let a few thousand people each look through their telescopes, there would be a chance for all the people in this world who wanted to see, to see.
The whole thing is the sun.
The whole thing is the sun.
Dobson was once a chemist, then a monk. Now he is a teacher, helping to rekindle curiosity.
Well, thank you.
Don't thank me. It's your son. Come see the sun.
Is this a study that you're doing?
No, this is a study that you're doing. Have a look.
Oh, okay, I'll look.
Now, the big green ball.
Dobson builds his own telescopes. This one he designed to safely view the sun.
And then after that, we run it through a welder's glass in here. That's what makes it green.
Oh.
You can't see a big green ball in there? Hang on. Now, the fact is that the parks already have the best seeing conditions. And so if we're going to get the telescopes to where the public is associated with the best seeing conditions, we have to do it in the national parks.
There's no green sun.
What? No, the sun isn't green, but it looks green in here because we have a welder's glass in here. But that big green ball is the sun. Look again. That big green ball is the sun, okay? And those dark spots that you see are on the sun. And they're bigger than the Earth. They're bigger than Crater Lake. They're bigger than Oregon. There's something inside you that drives you to understand this universe. It's not something you have to think about. There's something that drives you to understand how things work and how the universe goes, why we see what we see. Why is it like this? Why isn't it some other way? Why isn't the universe made out of butter? Why does it have to be made out of these little tiny things that you can't cut off any further? The spot on my side is a little bigger than the Earth, and it just came around from the other side of the sun by the spin of the sun. I used to wheel that telescope around the streets, and then some kid would say, "What's that?" And I'd say, "It's a telescope. Do you want to borrow it?" Well, of course he wants to borrow it. Then we'd put the telescope in some kid's garage, and then I'd sneak away from the monastery at night and come over and shoot off my trap at the eyepiece, like we do here, so that the people could understand what they see. Well, some of those kids, you see, who looked through that telescope, wanted to make telescopes of their own. And I thought, oh, Lord, if I help those kids make telescopes, I'm sure to get thrown out of this monastery. So I got thrown out of the monastery.
To Dobson, a telescope is a means to an end, a tool for people to connect with the universe and begin to understand it.
To see the universe is one thing, and to understand what you see is quite a different thing. And so we try to get them to see a slideshow, and so you can talk about what's the whole thing all about, what's the universe made of, on what kind of energy does it run, like that.
Physics is about the behavior.
Nighttime is when Dobson really shines. Before unveiling his telescopes, he teases their minds with questions. He calls this a star party. The only price of admission, curiosity.
You can ask any kind of embarrassing question. As I said, if I don't want to answer, I won't have to answer. Yes?
I'm wondering about these black clouds you can't see stars beyond.
Those are the kind of things that you're sitting on. You're sitting on one of those clouds. The universe has 3 ingredients: hydrogen and helium and the dust of exploded stars. And the Earth is made of the dust of exploded stars.
To Dobson, astronomy is the people's science. The universe lies open to all. Everyone can learn how it works, how it began, how it's expanding, and how we have come to know it.
The distant things are shifted towards the red, and we usually understand that to mean that they're going away. Now, the big problem was, why are they all going away? So the simplest explanation was that there was a big explosion called the Big Bang. You must have heard of it. The Big Bang. And because of that, all the distant things are going away. But we like to show you samples of these different kinds of things. Gaseous envelopes around old stars, the clouds from exploded stars. We like to show you all these different kinds of things and some planets.
A clear night, people eager to see. Dobson asks for nothing more.
Cheerio, the Fruit Loop before. Now we want to get M13. M13 is a globular cluster. This is a public star party. This is in a national park, and this is where we take the telescope so that the general public can see these things, which they can't see other places. And what we try to do is to show the bright objects, the important objects if you want. Okay, please climb fast like a chimpanzee. You'll see the thing drifting in from the upper left, and it'll drift across to the lower right, but you'll come down long before that so that the other people can see. You'll see Saturn to the upper right. It'll look like a straw hat. It takes light 1.5 hours to come from Saturn.
For centuries, astronomers studied only what could be seen. Aided by technology, they now see what before had been invisible. Visible light is only one way to investigate the universe. Astronomers now use the entire spectrum of radiation. But these investigations have revealed a mystery that lies beyond all these ways of seeing. There is a dark side to our universe. Most of the cosmos is made of something astronomers cannot see at all: dark matter. Vera Rubin is an astronomer at the Carnegie Institution of Washington. She played a key role in the discovery of dark matter. It was natural curiosity that fueled her desire to become a scientist.
I started looking at the sky probably at age 10 to 12. I just got hooked on watching the stars. Within a short period of time, I really got more interested in watching the sky than in going to sleep. So I went to the library, read books, built a little telescope, and just decided I wanted to be an astronomer. I had a physics professor in high school who didn't really know how to relate to a young girl who was interested in science. When I finally went up to him and told him I was going to college on a scholarship, he said, well, you should do all right as long as you stay away from science.
Rubin became an astronomer, specializing in galaxies. Her work led to the startling discovery that most of the matter in galaxies is in some dark form that we cannot see.
I mean, ideally, what we all dream of is that when you do when you ask questions in science, when you ask questions of nature, you will get answers that are much bigger than what you went out to find. They may raise enormous questions, which this has done, but also it made other little puzzles fall into place. And the combination of those things really is a very rewarding result from any study.
Rubin studied starlight captured on glass plates called spectrograms, patterns which reveal the motions of galaxies. A galaxy consists of stars and gas bound together by gravity. Astronomers had assumed that most of a galaxy's gravitational force comes from the luminous center, where most of the stars reside. If this were so, stars close to the center would orbit more rapidly than those farther out. But this was not what Rubin found. By analyzing the spectra, she determined that stars in the outer regions were moving nearly as fast as those closer in. If gravity came only from the luminous regions, stars moving this rapidly could not stay in orbit. The galaxy would fly apart. The conclusion seemed inescapable. Galaxies are held together by an invisible halo of dark matter.
I was really interested in learning something about the way the galaxies were made, were put together, how their mass was distributed. But I was not smart enough to think I was looking for mass, which we don't see. What's missing is the luminosity. So we know there is mass there. So a better name might have been the missing luminosity. That is, where is this matter? Dark matter is a good term. Unknown matter may be a good term, but the fact that it's dark is its most prominent characteristic. I like dark matter. In a galaxy, it looks like most of the light is at the center, and therefore we had expected that most of the mass would be at the center. And just like in the solar system, where most of the mass is at the sun, you expect that as things get farther and farther away, they orbit more slowly. And what we found is that these stars are going just as rapidly as those stars, and we're forced to conclude that they're responding to a gravitational field we don't see. And that gravitational field must be composed of dark matter.
Well, it's quite possible, in fact very probable, that the dark matter actually controls the fate of our universe, in the sense that it appears there's so much of it around that it dominates the gravity of ordinary systems. You know, astronomy is biased towards things that glow in the dark, and it's sort of amazing to think that when you look out at the night sky that there might be 10 or 50 times as much stuff out there that you really don't see, that in fact is controlling the fate of stars and galaxies and the universe as a whole.
Tony Tyson is an astronomer from Bell Laboratories. He's a leader in the search for dark matter. Tyson's work requires the use of the world's largest telescopes. That means traveling to distant observatories. Like many of today's astronomers, Tyson began his career as a physicist.
Studying the universe is basically physics. The question we want to answer is the question of physics in the universe. That's the fundamental question. How do things work? How does gravity work? Over what scales? Things of this sort.
Gravity dominates on the largest scales. The planets, stars, and galaxies all are ruled by gravity. But gravity also affects the tiny particles that form light. Gravity from a large object will bend light. The object acts as a lens, distorting the background image. Astronomers call these curved images gravitational arcs. Light will be bent by any dark matter contained in the foreground. Tyson is searching for these gravitational clues. Gravitational arcs can arise from any type of matter, luminous or dark. Chile, the town of La Serena. The nearby observatories make La Serena a natural stopping-off point for astronomers. Beyond the town, the land is sparsely settled by peasant farmers. In the foothills foothills of the Andes lies one of the world's major observatories, Cerro Tololo. Observatories are worlds unto themselves, outposts in our quest to know the universe. Astronomers usually come for 2 to 5 nights on an observing run. The routine is much the same at observatories all around the world. Sleep during the day, eat in the afternoon, and work all night. Tyson has come to Cerro Tololo for a 2-night run. Assisting him is Raja Guhathakurta from the Institute for Advanced Study in Princeton.
Okay, let's see, got 3 of these.
Tyson's search for gravitational arcs begins by finding places in the sky that appear empty.
See anything interesting? Places where there aren't things like that? It seems a little strange for astronomers to do to look at places in the sky where there's nothing, but in fact, what we found was that there were just lots and lots of galaxies in these rather tiny fields where there just happened to be nothing on these photographic plates. We found 1,000, typically 1,000 faint blue galaxies.
Galaxies are the building blocks of the universe. Usually they occur in clusters containing thousands of galaxies. Probing the darkness beyond the clusters, Tyson discovered that the space was not empty at all. There he found numerous faint blue galaxies. These galaxies provide a luminous backdrop, a curtain of light that Tyson can use to search for gravitational arcs. The light from the background galaxies will be bent by any dark matter contained in the foreground. This creates gravitational arcs, the fingerprints of dark matter.
Knowing that the sky is peppered with this backdrop of roughly 20 billion faint galaxies, we can use those faint galaxies as a tool to study the foreground dark matter.
Tonight, Tyson will use the largest telescope on the mountain, a reflector whose mirror spans more than 8 feet. Fitted out with the latest electronics, this telescope is one of the most powerful in the world. The control room of a large telescope resembles a flight deck, crewed by a pilot, a navigator, and a man at the helm.
I can move it down if you want. Thank you.
Astronomers seldom get more than a few nights of telescope use in a year, so observing runs are well planned.
Every second counts. This is a big telescope, and we get very little time on big telescopes. It's very highly competitive, and we have lots and lots of observing to do.
Tonight, Tyson will aim the telescope at several targets. Charts and star maps are used to navigate.
Yeah, I'll do that in a second.
Okay. This gives us a nice finding chart. It helps us find our way on the sky, if you like. I mean, you know, by looking at the stars there and comparing it with what we're seeing now, we can tell whether we're in the right part of the sky or not.
To search for gravitational arcs, Tyson must meet 2 objectives. Image the background galaxies, then find a foreground cluster. If the cluster contains dark matter, Tyson should see gravitational arcs.
That's just about right. Okay.
To succeed, Tyson must look deep into space, pushing the telescope to its limits. A telescope is a time machine. Tyson looks back to a time over 12 billion years ago, when the first galaxies were forming and the universe was emerging from darkness. Tyson's first stop is a seemingly empty region of space. The background galaxies are much fainter than the natural glow of the night sky. To distinguish galaxies from electronic noise in his detectors, Tyson jiggles the telescope. Eventually, the faint blue background galaxies appear. Now, Tyson must find a foreground cluster. If the cluster contains enough dark matter, the light from the background galaxies will form gravitational arcs. Though dark matter is invisible, Tyson believes his technique allows him to create pictures showing its shape and distribution.
The most significant thing about what we're doing currently is that this is the first time that we've been able to actually see dark matter. We can actually image the stuff and get a picture of it. And these pictures, the way it appears on the picture, if it's clumped or stringy or just a nice little round blob, I think is going to end up telling us something about its nature and about the history of the universe and the way things eventually clump together under their mutual gravitational attraction.
Tyson records his images on computer tape. Only after careful analysis can he be certain he has detected dark matter.
Well, I thought I convinced myself a few minutes ago that I could see some more blue arcs in this thing, but we'll have to wait for the data reduction. This is the final production image in color. These fuzzy yellow things and fuzzy red things, those are the galaxies that are in the cluster in the foreground. And see all these blue guys? Those are all distant galaxies, way, way behind the cluster, many times further behind the cluster. And there are visible by eye many examples in these blue galaxies where they're aligned along circles centered on the center of the cluster. So these galaxies have been stretched. Their images have been stretched by the gravitational lens effect of the cluster. All the mass in the cluster causes these galaxies to appear at a different place on the sky than they would have otherwise. And as a result, their images have also been distorted systematically into these segments of circles around the center. And what Raja and I are going to do now is to start up some software which will analyze this final production image. It will create a picture of the dark matter in the cluster.
Using a computer, Tyson creates a simulation of the gravitational effect of dark matter.
What we do is we simulate the universe and then compare the results with what we find through the telescope. And it'll tell us if the simulation is wrong or right. And when we get a good match, then we move around in parameter space to see how robust that match is. And that tells us quite a lot about what's really out there.
Using this technique, Tyson estimates that 90% of the universe is in some unknown and invisible form. Dark matter lies not just in the distant universe that Tyson explores. It permeates the universe around us. All that we see is only the tip of a greater universe submerged in darkness. John Dobson, once a chemist, once a monk, now he's a teacher and an evangelist about astronomy.
The reason I got into this telescope-making world is because I wanted to help make it possible for people to see this world. And that's why we made these user-friendly telescopes. They're not designed to entertain photographic plates. They're for entertaining soft, warm eyes. Because seeing things in photographs is a very different thing from seeing them with your eyes through a telescope.
Summer, summer, Dobson travels to parks and small towns. He stops wherever people gather, giving his talks and holding his star parties, preaching the joys of astronomy.
You see at all these places you go, there are so many people who are terribly interested in these things. And then you have to understand that the population of this earth is several billion, and all those eyes are waiting to see, all those ears are waiting to hear, all those minds are eager to understand. And somebody's got this job to do.
In the span of Dobson's life, astronomy has dramatically changed our view of the universe. Not long ago, we knew of only one galaxy, our own, the Milky Way.
See, when I was a kid, the universe didn't look like this at all. We only knew that we had one galaxy, our own galaxy. Nobody talked about galaxies in those days. They were called spiral nebula, the Great Spiral Nebula and Andromeda, all that kind of stuff. All that's changed. And when Einstein came up with his gravitational theory, that's really when cosmology got going. And also because at the time we found out that there are galaxies outside of our own, and we wondered how far it goes. And so really the scientists took this broad view in the early part of this century, and that's running wild now.
At home in San Francisco, Dobson gives classes in telescope making at a nearby museum.
The classes at the Academy of Sciences, they have a big enough mailing list so that they can get enough people together to run a class. And the class runs for 8 weeks.
Dobson is well known among amateur astronomers. The Dobsonian telescope design is world famous. The instruments are hardly high-tech, but they're easy to build and a joy to use.
Rough grinding is a caveman's job. That's what we do this week. Rough grinding is a caveman's job. Eat well, sleep well, and work like hell. But there's nothing about it that we don't know how to do, and there's no boo-boo that you can do in this class, which will be followed by a life of sorrow. The worst state you can possibly end up in is not having a telescope, and that's where you are now. I want them to see the universe. As I said before, I want them to see the universe, because if they don't see what the universe looks like, they won't wonder about it. And if they don't wonder about it, they're dead. What's the use of somebody that doesn't wonder? It's the hallmark of our species that we're continually wondering what's going on. But the specialty of these things is that they move easily. They go wherever you push them, and they stay wherever you leave them. But they don't track things across the sky. They're not good for photography, no. If you want to do photography, well, in the first place, you've got a disease, because all the pictures have been taken by Lick Observatory, and all you have to do is go and buy them. You can't buy film for the price you can get the pictures. But nowadays, what they do is to make this kind of a mount anyway, even if they do want to do photography, and then they put this on a Ponce mount. Now, Ponce is a Frenchman, and he writes to me, and he apologized from France, and he apologizes for redesigning the Dobsonian. Anyway. He thinks that's real funny. And what we're going to do is... When I joined the monastery, I was working in the atom bomb project, the Second World War. I was working for the University of California, the radiation lab. And in the monastery, I became keenly tied up in these cosmological problems, if you like to think. So I wanted to see what the universe looked like, and so I helped somebody make a telescope, and then through that telescope, we saw the third quarter moon. And as soon as I saw that third quarter moon, it looked as if it were coming in for a landing. I couldn't believe that the moon would look like that. And I thought, my God, I mean, inside of me it said, hey, my God, everybody's got to see this. Oh, now here's a polished one. These people start with a raw hunk of glass. And then, even with the unsilvered mirror, they look at the moon and they can see all those craters. They're flabbergasted. That's what gets everybody.
I'm not interested in telescopes. I really not. And if I had to just sit around making telescopes for sale, I'd be long gone. I really am not interested at all. Now, see all these people, the reason they're connected with me is because I stand for something, for some information about this universe. They're not interested in me. They're interested in the information, and they've never seen this information put in a package before. That's the fact. In there. All right.
Keep going. Nothing's happening.
I'm trying it.
Alicia, your mirror is too deep in the hands and a little bit flat in the fingers. Somebody sticks around when he feels that he's got something to do. You know, old people that don't feel that they have anything to do and they feel that their friends don't love them anymore, they die fast, okay? People who feel that they have something to do and they've got friends whom they care about, they don't die out like that. I'm one of those guys. Get you out of the way, please. Well, the song is an old thing. It's Shankara's, and Shankara is something like 800 AD or something like that. And his view is that behind this whole universe there's just one reality. Om Vishwam Darpana Drishyamananagari Tulyam Nidantar Gatam Pasyanatmani Mayaya Bahiriboda Bhutam Yata Nidraya Yah Sakshi Kurute Prabodha Samaye Svatmanameva Vyayam Tasmai Shri Gurutaye
On the big island of Hawaii is a dormant volcano sacred to Hawaiians. At an elevation of nearly 14,000 feet, the observatory on Mauna Kea is the highest in the world. At this elevation, minds grow fuzzy, muscles ache, and breath is short. But astronomers dream of observing at Mauna Kea, for here is where the answers to today's celestial mysteries may be found. To continue his work on dark matter, Tony Tyson has been granted another observing run.
This kind of research isn't very glamorous. It's a lot of hard work. The observing can go well sometimes, sometimes not. It's long hours, and the successes are occasional, but when they happen, it's fun. There'll be generations of researchers after me who will still be researching the dark matter problem. Basically, all we're trying to do is to provide some limits to how it clusters and where it is so that people can try to understand what it is. Okay, well, being optimistic, I'll put the tape on anyway. There is an aspect of being close to nature, of being alone with nature, in fact, that science has, not just astronomy, but any kind of scientific research.
The fundamental question that astronomers would like to answer is, what is dark matter? What is this stuff that does not shine? Planets do not emit light as stars do, so planets are a form of dark matter. But astronomers doubt there could be enough planet-like objects to account for the amount of dark matter they believe exists. Scientists have turned their attention to subatomic particles that may have been produced in the Big Bang. Even today, vast numbers of these particles may be passing through our bodies every second. They may control our fate and the fate of the universe. For the amount of dark matter that exists will determine whether the universe expands forever or someday begins to contract.
Well, I think life on Earth has a lot to do with the universe as a whole. I think our perception of ourselves is somehow shaped by the way we view the universe around us. But it's difficult to go through life realizing that over 90% of everything in the universe is something you know nothing about, and it may be made out of particles that are zipping through your body even now. I think it's certainly worthwhile trying to answer that question. Build machines that will try to answer that question. Unless you take the risk. and build the equipment and design the experiment and ask the question, you don't ever get any closer to the answer, and you don't ever get any closer to nature. It's totally up to the
We have to
programmer.
write something like that, because he writes something like that yesterday, but I don't know what.
When there's some ennui that
Astronomy has become big-budget science. Access to major telescopes is competitive. Sometimes it takes great ingenuity to conduct unusual experiments.
You get some crazy idea in your head, right, that you can't get rid of, and you want to test it. So you design an experiment to test the idea, and then you try to carry it out in the laboratory or in physics or in astronomy with a telescope, perhaps. We did a bizarre experiment in '84 by pointing the telescope at a place where there was nothing on the sky. It was done secretly because there's no way that you could get a committee of astronomers to agree that this is top priority. But when we started finding things, it got real interesting.
Tyson's chance discovery, the faint blue galaxies, became a new tool in the search for dark matter. This is the way of science. New discoveries lead not only to answers, but also to new questions.
The idea that dark matter is around us has been around since the middle of '30s. It was simultaneously discovered that, on the one hand, there was something in our galaxy pulling stars back, stronger than the gravitational pull of the known stars. And roughly the same time, galaxies in clusters of galaxies were found to be rushing around faster than the local speed limit, which is set by the gravitational pull of all of the galaxies that one can see. So there was something there, some extra mass. We're turning back now. The guide camera's ready. Are you guiding?
That 90% of the universe has some invisible and unknown form is an accepted astronomical fact. The puzzle of what it is now ranks as one of the great mysteries of the cosmos.
Find the stars and galaxies and scribble in our nightly logs. Some major, minor, Vela, Virgo, Bolins, and Vulpecula is where we plan to aim tonight with $1,000,000 specula.
Kevin Krisciunas is an astronomer who works year-round at Mauna Kea.
In hot pursuit of photons there and world-beating science. Songs like this I have actually had to write. Well, let's say I did write them in preparation to go give talks at astronomy conferences. There are a number of important considerations in choosing a site to place a $10 or $100 million telescope. You want it to be clear often, which it is at Mauna Kea. You want it to be dry so that you can do infrared astronomy. And you want to be within 50 miles or so of the ocean, because they found that you get a smooth flow of air over the top of the mountain, and this leads to very steady images.
The clear air of Mauna Kea attracts astronomers from all over the world. Half a dozen countries have built telescopes here, and more are planned.
We are through Millimeter Wave Valley, and we are heading up towards the mighty Keck, which will be 4 times the power of the Palomar Observatory telescope, and will, by a long shot, be the world's largest optical and infrared telescope.
The size and innovative design of the Keck telescope will provide better views of the universe than ever before possible.
There are 2 unusual things about how the telescope is designed and will be built. One is the mounting, and then it's an alt-azimuth mounting similar to a Dobsonian mounting because you can build it cheaper for any given size telescope. This one, of course, has to be computer-driven. The other unusual thing is that it will have a mosaic mirror. Rather than a single piece of glass, this will have 36 hexagonal mirrors, 1.8 meters in size.
Astronomers use the term first light when a new telescope first captures starlight. The Keck telescope saw first light in the autumn of 1990.
At the other end of the Keck dome, it is within the realm of possibility that they'll put another telescope just like it, so that you can combine the signals of both telescopes as if you had 10-meter binoculars. This is beyond the technology at the moment, but in 10 years or so, who knows? At last, here we arrive at the summit of Puupoliahu. We're at the summit of Puupoliahu, the second highest cinder cone. But as you can see before us, there's this beautiful panorama along the summit ridge and in the valley in between of the jewels on the mountain. When I was a kid, I thought, well, maybe if I'm lucky, I'll get to grow up and play with things that I couldn't afford myself. And so I feel like I've done my fairy godmother a turn in reverse by studying hard enough to get a decent enough job to work with this kind of equipment with the other people that come up here. For those occasional nights where something really, really exciting rolls off the telescope, it's great to be here at the forefront of technology and science.
Vera Rubin, an astronomer at the Carnegie Institute in Washington, remains intrigued by the problem of dark matter. For now, she's involved in other projects, moving forward to new problems and new challenges.
After Andy and I were at Palomar, I went off to Kitt Peak and I took some spectra of not normal field galaxies. And they really
there are enormous ways to get pleasure in doing science. I've just come back from 3 spectacular nights and see things on my spectra that I've never seen before. This is a very exciting time. So every day is really very exciting. I don't know what will come out of this. I don't know whether it will be major or minor, but it is an enormous pleasure to see things you've never seen before and to attempt to understand them.
In downtown Washington, every Saturday, the Carnegie Institution opens its doors to the children of the neighborhood. This program is called First Light.
Planets that are going around it. And this is a model of all of the planets around our sun. But it's really very, very, very many times smaller. Yes? We all recognize the really severe need to interest youngsters in science. That, you know, in the year 2010, these are the kids that'll be doing science. No, it's over here.
Rubin is one of several scientists who help the children of First Light discover the joy of science.
Okay.
Dobson's students have now completed their telescopes. Now he takes them on a star party. These telescopes, too, are ready to capture first light.
This is the stardust.
Whether their telescopes are small or large, all who look to the skies and wonder are astronomers. They delight not only in seeing, but in the endless struggle to understand.
What we're doing really is an experiment in experimental physics. It's a mystery. The mystery is the mystery of dark matter. I don't think that that's leading us to any great new philosophical or theological worldview or universe view. It's solving an interesting problem, and it's exciting and fun.
you're looking at that side, you'll see that one side is light and one side is dark. It's been almost 10 years that we've talked about this dark matter, maybe even more, for real. And I thought 10 years would give us the answer, and it hasn't. And I think that means it's a tougher question than we thought. And I think it may be full of surprises when it comes out.
Everybody's tied into what he feels to be real, okay? And when he looks out with the telescope into that vast, almost empty darkness, he knows that is real. Everybody gets that feeling. And some people get swept away by it, really swept away by it. Their life gets completely changed just by looking through these telescopes, really.
We all ground our own mirrors, I suppose you know that.
Tomorrow at 11 o'clock, the Astronomers considers the mysteries of quasars and black holes.